Hello everyone. So if you are following my course, you must already be knowing. In the previous session, we have developed a multi-agent system using hands-off and agent test tool design patterns, which are provided by OpenAI SDK. And previous to that, we have covered OpenAI Agent SDK foundations and covered various topics like how to create agent with the OpenAI Agent SDK, functions tools, runner, structured output, and tracing. And in the first 6 sessions in part 1 foundations, we have developed a simple AI agent, then intermediate agent, and then converted into a reliable agent and chatbot with Streamlit. The important point to notice there is no framework or agentic framework we have used while developing these agents. Now, strictly talking about from this session point of view, knowledge about OpenAI Agent SDK Foundation is strongly needed because we are building guardrails and tripwires on top of that. Multi-agent handoff, well and good, but knowing about part 1 foundation, it's not recommended as such, but definitely suggested. This is because you will appreciate more by knowing how much each new functionality is helping us removing something which we are doing manually earlier. You will not be even appreciate OpenAI Agent SDK if you do not know the pain about manual JSON schema or building a while agentic loop. Similarly, you will not understand or appreciate guardrails and tripwires if you have not built the agentic pipeline without anything protecting it. So this is why I will suggest you to go to part 1 foundations if you get the time. Now let's start. So by session 8, we have developed something genuinely impressive. We have developed a multi-agent research pipeline with each agent focused on one job. We are getting the structured output with full tracing throughout. And we know something which is working fine doesn't mean it is working safely and securely also. So in our program, nothing stops user from entering malicious inputs. Nothing stops prompt injection hiding in the search result and hijacking agent behavior mid-pipeline. Moreover, till session 7, we had just one entry point to validate. Now we have 4. So one check is no longer enough. And if you think you can handle this situation by adding more instructions to the agent, think again. Because system instructions just act as an advice to the LLM. LLM are free to ignore them. So this is why we need a safety layer that wraps the agent lifecycle, that sits outside its execution. And if something goes wrong, it aborts the whole thing. This is what session 9 is all about. Guardrails and tripwire. So it provides safety layers that turns a working pipeline into something that you can actually put in front of your users. So let's go through some of the key concepts of guardrails and tripwires. So what guardrails are? So guardrails are the runtime checks that run the run lifecycle. Important point to note, they are not embedded in the business logic. They run outside the model. So this is the reason model cannot bypass them. So if you can see here, when your runner.run program runs, your input guardrail runs alongside with agent pipeline. And output guardrails, yes, output guardrails are also there. We will talk about them. They run before the result is returned. And then there is a tripwire mechanism. When the guardrail runs, tripwire trigger becomes true. It's a boolean. The SDK halts the entire pipeline immediately so that there are no partial state escapes. Think of it as an atomicity for the pipeline. Either everything succeeds or it will completely fail. So let's see a very quick example of tripwire and guardrail. We will again go through it when we will actually build this program. So you use the function decorator and convert the function into a guardrail. It is basically checking some of the block phrases. If your program or if your instructions have any of these block phrases, then your should block, this is a boolean which becomes true, and this is the guardrail in which the tripwire trigger becomes a true and your program will abort. We will come through this piece of code again when we will go through the program. Guardrails versus moderation. They are different layer, do different jobs. There is the moderation API which OpenAI provides, which sits inside the guardrail function. Moderation job is content safety, so that there are no biases, no harmful content, no violence, hate, or harassment related content, which can be provided as input to the LLM or something which can come as output also. And guardrail function is different. They provide the workflow integrity, whether it is a valid research or not, whether the output is usable or not. Important point to note is for moderation, we use the same OpenAPI key. It is built per text process, not the LLM tokens. It is kept very cheap because it runs twice per query, both for input and an output. Guardrails for system prompts, we talked about it. System prompts are advisory, model may ignore them. Guardrails are enforced. Model cannot bypass them because guardrails runs outside the agent. Input and output guardrails we just talked about. Input guardrail run parallel with the agent. They are not blocking upfront. Now why output guardrails are needed? Because suppose that you have a search agent which pulls web contents that is harmful and that can come into your final reports. And similarly, there can be quality checks you can perform with the help of output guardrails. So tool safety, yes, there is a parameter you can enforce whether the tool should be run or not. We talked about tool safety briefly when we covered the program in the previous session. So if you see this screen, this is the tool safety settings. So we are here enforcing that your search agent should be using the web search tool provided by OpenAI. it cannot bypass it. Another thing, guardrails plus run context wrapper. Guardrails get the same run context wrapper. We talked about the run context wrapper in the previous session. So they get the same context as the tool and agent, and they can inspect your program state. So for example, let's say search has bring the result, but the source text parameter is none. Then you can block the output, you can abort the program because there are no verifiable sources that are available. So now I hope the basic concepts of guardrail and tripwires become somewhat clear to you. Let's make them more clear by going through some of the guardrail programs, and after that we will cover type of guardrails. So in order to save us some of the time, I have already keep the basic structure ready. I have already created the .env file with OpenAI API key and created these two programs, one which will cover the input guardrail and other which will cover both the input and output guardrail. So let's go through them one by one. On the top, if you see here, we have some of the familiar import statements. Any of these import statements does not work for you. You have to use these pip commands. As you see, we are just importing some of the basic built-in blocks like agent, runner, tracer, with some of the new things like guardrail function output and input guardrail tripwire from the agent exception module. And after that, this basic logging statements, we are going away from the using the basic print statements and then importing our .env file. And let's see here, we defined our first guardrail. We have the function which we have converted into guardrail using the input guardrail decorator. And this function is taking three things as an input, which is run context wrapper. We covered it. Here we are not passing anything in the run context wrapper. And from this program perspective, it is taking just the agent as well as the input which user is providing as an input for this function. And it is returning guardrail function object as an output, which has two fields. Output info, this is for our own purpose, and tripwire triggered. Now this is the tripwire mechanism which we have talked earlier. This will give the indication whether to abort the program or whether to keep the program continue. So this is just a boolean. So if you see here this function, what it is doing, whenever it will be triggered, if the user input has one of these keywords, then it will allow it to continue. But anytime if it is not there, then it will trigger our guardrail. So when we will execute the program, you will understand it more. And then we are declaring our agent. You are seeing it here. We have seen it multiple times. It has name as well as instruction, new parameter, which is input guardrail, which has this function name as an input. And then if you see here, we are just running our program. This is the entry point and it will just run the run function. And if you see here, we try and accept, we tracing on, we are running our agent and just printing the output. Right. So when we will run the agent, you see here, and this agent will call the input guardrail function. And if our input does not have one of these keywords, the program will try to abort. So let's see how. So the question which we are asking is, what is the best recipe for this pasta carbonara? It does not have any of this text, which we are thinking like user should be asking something related to the AI, machine learning, etc. So let's try to run this program. So you see here, it is just printing the question and our guardrail is triggered and giving us the output. So the exception is fired here, you see here, and it is saying like guardrail info is the output info which we have defined it here. So the guardrail is triggered and the program has not continued, the run is not succeeded. Now let's try to do the opposite. We will change the question here. We'll keep this as a, we'll comment this one and add this one. So this question now has an LLM and neural network. LLM is one of the allowed keyword. Let me just run the program once more and see, we have now got the output. So this means the program has succeeded. The guardrail is not triggered. But this is very brittle type of check. This is just to make you aware that what is input guardrail is all about. Obviously, you can very easily bypass it by asking something like this. What is the recipe of pasta carbonara and what is LLM? So if we will ask this question, let's see how it responds. It is able to giving me the response. So it is not the best way to implement it, and that's why you will learn why we have a different guardrail types which help us to avoid this kind of situation. I hope like you get the idea of input guardrail. This is similarly we have input output guardrail both available. The import statements are mostly similar. With just we have another exception class defined output guardrail this time, and the packages are same. You don't need to install anything new here, and we are importing our .env and then defining the input guardrail, similar kind of topic check, but this time little different. It has blocked phase instead of allowed phases. The user cannot ask this kind of phases like write Python code or ignore previous instruction. And then we have the output guardrail also, which is doing the quality check of the output. So that is why it is taking the output. And output, but how we have defined as a pedantic model here. So this is our, we're forcing our LLM to return the output in this way, which it should have the summary as well as the bullet points. If the summary is less than 40 characters, then it will, our guardrail will trigger. And similarly, if it has less than 3 bullet points, then again our guardrail will trigger and it will block. It will block it and it will try to abort the program because the object return is this guardrail function output. It will give us the output info and it will make the tripwire triggered as a true. Then we are defining our research agent. Its purpose is like, it gives a concise summary and at least three bullet points. And this is exactly which we are checking as an output guardrail, whether it has indeed give us three bullet points or not. And then the output type is the pedantic model. And we have defined our input and output guardrail. And then we are running our program with traces on. And if it is, the run is successful, the run succeeded. Otherwise, and we are printing the summary and bullet. And now let's finally talk about the exception. So when the guardrail fails, the SDK raises an exception. Now these exceptions are the object of input guardrail tripwire triggered class or output guardrail tripwire triggered class. And finally, we're printing the output info. Now output info, if you remember, these are the field inside the guardrail function output whose object is returned. Now you may be wondering how guardrail function output is related to exception, which is finally we are getting when guardrail fails. So for that, remember this chain. If you see here, you get the output info. Let's start from the bottom, which is the dictionary and holds the info about the guardrail failure. And this is the output, and this is actually a field inside the guardrail function output, which we have seen here, guardrail function output, as you see here. And then this is actually SDK wraps this object inside another object called guardrail result. And finally, this is then attached to the exception. And this is why we got this line. So just little tricky to follow it, but just remember output info. This is attached to the guardrail function. SDK wraps it inside another object, which is guardrail result. And then this is attached to the exception, which is fired. So in this way, we are able to print the details. Now let's quickly run the program and see how it behaves. So it should ask me for an input. Yes, it asked me to enter a prompt. So I'm trying to merge two instructions into one so that it looks like a real one, but at the same time it has this block phrase. So let's see how it works. And see, it is correctly giving me the error. The input guardrail blocked the run. This should block becomes true because it contains this instruction. The tripwire triggered should block become true, and it does not allow us to move forward. Now let's quickly see if we can somehow execute output guardrail because it is difficult as the instructions are coded in our agent. So if you see here, the research agent say like give us the concise summary and at least three bullet points, and these are the same thing which is checked by the guardrail. Let's first run the program, and I will say explain AI to me in one word. Yes, so it has basically blocked the guardrail, but for different reason. So you see the summary length is this, whatever it is returned, and the bullet counts came as 4, but summary length is less. Bullet count is still fine. Output guardrail has run. So you can see like I was not expecting that, but it has run this time. So I hope you get the idea of input and output guardrail. Now we can quickly move and cover the type of guardrails. The first one is the topic guardrail. We have covered that in our first program. So off-topic requests are blocked before the pipeline runs. So for example, you're asking a medical questions to the finance chatbot. So this is off topic. So the guardrail should be able to stop the program. And if you have seen, this is exactly what our program is doing. The first program is doing. So if the topic is outside of this particular list, then it is aborting the program or blocking the execution. The second is the harmful content guardrail. So it catches toxicity, hate speech, violent content, bias, all those things, and it runs on both our input and output. So this is done by with the help of moderation API, and we are going to cover this one in a separate program. The third one is the PI data leakage guardrail. So it blocks the exposure of personal information like name, email, phone number, address. So it can be regex based, fast, where no API is needed. But what I see, which is more recommended, is the API which is provided by Microsoft because it can do so many different kind of checks. We will cover a small example of this soon. And then the prompt injection guardrail. This is similar to what we have doing in the second program, if you have seen. So this is actually the prompt injection. If we can ask this comment like, ignore previous instruction, forget your role, all those kind of block phases, if we use and somehow we make our agent to forget the system instructions, right? So then this is a prompt injection, and this is why we have written our guardrail so that it prevent any such kind of malicious user input. And then there's a malicious code guardrail. We are not covering it, but the key is that if there is a dangerous pattern, script tags, shell commands, evil calls, all those things, then the model should be able to prevent the execution. And finally, relevance and fact guardrail. This checks the output quality standards, minimum length, required sections, structured findings, all those things. So we have covered this one just in our second program and see it has worked. And by the nature of it, it is just valid for the output guardrail. Now let's try to cover the harmful content guardrail. So for that, we will write a new program. Let me create a new file. So this is our program which will use the moderation API. Let's quickly cover that. The import statements are quite evident. We are familiar with these statements. we are loading the .env like we have done earlier, logging we have done earlier, and this is what we are creating the moderation client because we have to run the moderation API. It will run in async. That's why we are creating initializing async OpenAI class. So if you see here, we have this in this function, we have this input guardrail. This is same which we have done earlier. There is nothing new about this guardrail. User input has any of these keywords, then it allows it to succeed. Otherwise, the guardrail will trigger and the program execution will be blocked. But this is new now. This is a second guardrail. It is the moderation check. And if you see here, within this function moderation check, yes, it is taking the same input, run context wrapper, input, whatever is the user input. And then if you see here, it is running the moderation API in the same format which we have covered, I think, in the session, I think second session in the LLM orchestration. The format is near about the same. You're running the method moderation.create by passing the model as well as the user input as the parameters, and you're getting some response. If the response contain any of such harmful content, which we have talked about, like bias, self-harm, all those things, then the flag will become true, and it will also here give the categories, the harmful categories. And after that, we are just creating our agent with name, instruction, and input guardrail. As you see, both the moderation check and topic check guardrails are passed as a parameter. In the last, we have the run function, which is called from our entry point. And I'm not going to cover this function in details. As we have gone through a couple of times in the past. So within the try statement, we have been tracing on, we are running runner.runnerSync and printing the result. And if we will get the exception, which means the guardrail has thrown an exception, then we are capturing some of the details and printing it. So let's just try to run this program. There are multiple inputs which we can try. The first one is a difference between LLM and neural network. I'm not going to run it, but it is expected to pass because the first guardrail should not block it because one of the accepted topic is present in the prompt. The second is the best recipe for pasta carbonara. So this particular guardrail should fail. The topic check guardrail should fail. Check it yourself. But let's run this third input statement, which is what AI models are best at generating content that glorify violence. Now, since it contains the statement violence, then the moderation API, the moderation guardrail should kick in and try to block the running of the program. Let's see how it behaves. So this is little curious results, strange results we have got. Our moderation API, the flag become false. It has not flagged it as an harmful content. Maybe it is talking about AI models, not specific the violence acts. So that is why the moderation API check has passed. But since still the API inside checks, because after that our agent has run, which is going to talk answers about AI and technology. So it has kicked in, which should have called LLM internally, and that LLM basically give us the response. I'm sorry, I cannot access with that request. So even with moderation checks failing, the LLM internal checks are not allowing to give the result. That's an interesting result. Now let's quickly comment this and try to run a statement which explicitly talks about the violent. So we are saying describe AI and the violent state fight because we are talking to describe AI, then it is expected to pass the first check, the topic check. But the moderation API should fail this time. So let's see how it behaves. And yes, as we have found, I think this time the moderation API kicks in and the flag becomes true and it is blocked because you see here the violence category has become true and other categories have come false, but it is blocked by the moderation check. So our program ran fine. Now let's move to the PIE data leakage guardrail. As mentioned earlier, it blocks exposure of your personal information like name, email, phone number, and addresses. It can be done in two ways. The first one is regex based, which is fast, no API needed, but the downside is you have to build such regex functions yourself. But then there are certain libraries which are available outside that perform the same job more effectively, more reliably out of box. One such library is Microsoft Presidio. I'm going to show you a code snippet which leverages this library in a while. But before that, just look into this infographic. So if you see here, there are various open source LLM guardrail libraries that are available outside. One example is Guardrails AI, which performs output validation and risk mitigation. The another one is this Nemo Guardrails, which is provided by NVIDIA for data safety for LLMs. Not just provide input and output checks, which we have discussed so far, but also provide guardrails for RAG pipelines and tool calls. Microsoft Presidio, we are going to cover it today, not extensively and thoroughly, but you will get the idea. And then there are other libraries like TrueLens and Open Guardrails that are also available. But there are two concepts or two things that you have to keep in your mind. The first one, these libraries are platform agnostic. So they are mostly done outside of your OpenAI SDK, and you can leverage them in your pipeline for performing independent guardrail checks. And the second thing is OpenAI SDK guardrail provide just two actions. Either it let everything pass or it just block or abort the whole program. But these open source guardrails provide one another action which is scrubbed or rejected. So what this mean? For example, let's say for the PI data, instead of aborting the program in case PI information is found, it detects that information and pass the placeholder information. For example, in case of email address, it passes you just a text like email address instead of actual email address. So your whole program will run without getting aborted. Now let's quickly see how the PI guardrail works with Presidio library. If you so this is the example. In order to use this library, first you have to install this package Presidio Analyzer. Once it is done, you have to use this import statement and import the analyzer engine class, and then you initialize this class. Once that is done, all you have to do within your guardrail function, you can use the analyze method and pass the text which needs to be analyzed for the PI information, the entities that needs to be checked, for example, email address, phone number, credit card, and beside that there are certain other checks. If you see here, this library supports multiple other PII entity types, for example, person, date, time, age, NRP, email address, phone number we covered, IP address, UK bank number, location, US address, so many other information, and then the language also. And as you see, if this check is successful, then you can store the result in some list. So if so this variable is storing if the length is greater, then it means the PI information is found. Then you can trigger the tripwire based on this boolean. The rest of the function remains the same. So I hope you get the idea of the PI checks that can be performed with this library. So now we will move to our final frontier, the last section of this session where we will add guardrail to our research pipeline, which we have covered in the previous session, session 8, to make it more reliable and production ready. The pipeline there will remain the same. The same four agents will continue to operate in the same way: orchestrator, search agent, analyzer agent, and writer agent. But we will add three input guardrails that run before the pipeline start, and the three output guardrails that will run once the result is returned. But before going to the actual program, let's see how the production grade design approach for guardrail looks like. So there are three layers of checks in such programs. The first is regex or rule-based checks. We have covered that. We have seen how you can add such text-based or string-based checks for prompt injection and off-topic checks. Then we have covered the moderation API, which is effective but can only be used for harmful content. And here you will see we have added another layer of check called LLM semantic classifier, where we will leverage LLM to identify user intent for the similar checks which are performed in layer 1, the prompt injection and off-topic checks. So we will perform these checks twice. Why? Because any cleverly introduced prompt injection can be smartly recognized by our LLM. But there is a downside. LLM means it will incur some cost. So that's why companies use smaller specialized models for LLM classification, because they are faster and cheaper. For example, GPT-4 mini for classification and GPT-4 for generation. If you see here, I have given an example. So this is LLM based classification, where we are leveraging a small model judge, small LLM, to identify the user intent. For example, our agent is meant to answer question only for technology AI. So LLM job is just to classify whether the request is valid or invalid. And the max token is also very less. So it will get the decision and flag it invalid if needed. So now let's finally look into our research pipeline program in which we are going to add the guardrails. So remember, this is the program which we have developed in the last session, session 8. If you can recall, we have used two design patterns, one agent as a tool and second handoff pattern. So we will be making changes, adding guardrail in our handoff agent program. So we will start from the bottom. There is the main function. If you can recall, we are just asking user to enter the research topic. Then we are calling the hooks. Hooks, as if you remember, they are the call functions which are called automatically at some special point of the agent lifecycle. So like on the tool end or on the handoff, here we are printing some of the information. We will be making a minor change in the hooks in our new setup also. And then with traces on, if you remember, we are just calling our runner.run, which is executing the agent. Finally, we are getting the report in the pedantic format using our pedantic model, and then we are just printing it. So if you remember, our runner.runner is calling the orchestrator agent, and orchestrator agent is handing off to the search agent, and search agent is handing off to the analyzer agent. Analyzer agent is then finally handing off to the writer agent, which is producing the output in the pedantic format. So this was our old program. Now let's see our new program with the guardrails. As we have talked about, this is research pipeline with production grade 3 layer guardrails. So layer 1 will be having regex checks, obvious off-topic and injection phases. Second layer will be moderation check, harmful content we talked about in, and then there will be semantic classification, which will be done with the help of LLM. So it will perform the same checks which the regex has performed, but as you know, LLM will be more smart to detect any subtle and indirect cases or scenarios. So here also we will start with the bottom. So bottom looks same. We have the main function. In the same way we have hooks, and with the traces on, we are calling the runner.run. Once our agents have been executed, the report is produced and we are printing the report. The same way what we have done earlier, with the only change, if the exception occur, this means the guardrails get triggered, then we are catching the exception here and printing it. So this is the first change. And as you know, there are four agents. This looks exactly same. There is not much different except one thing, which you can tell me. And I think you have rightly guessed. We will have input guardrails and output guardrails. Now please tell me in which agent we will add the input guardrail and in which agent we will add the output guardrail. I think you must have correctly guessed it by now. So we will be adding our input guardrail in our first agent, which is orchestrator, because it is taking the input. So we will be performing our guardrails. There are three guardrails. One is regex check, as we have talked about, moderation check, and semantic classifier. We will come to these guardrails, and then in the writer agent, which is producing the output, the final, so it will have the output guardrails: output moderation, quality, contract, and validate sources. If you see here, these are the six guardrails which we have added. Let's go them quickly one by one and see how they are working. So first is our regex. So this is the input guardrail, and as you know, like it is string based checks. So it is have some, injection phases as well as the off topic phases which we have to catch. So if the user is doing any such off topic phases or putting some malicious input, then our program then catch them and it will be added in this match injection list here. Similarly, it will be added in the match off topic list. And then there are some research keywords. So we want that user question should belong to one of this topic. This particular boolean become false if either one of the above list is true. That means it is off topic or user has tried prompt injection. And if it does not belong to one of this topic, our tripwire mechanism will trigger and our program will get aborted. And this is the output info. We are just having some extra detail information here, which we are printing in case of exception. As you have seen in the bottom, we're printing it here, the output info. This will give me all such information which we have seen above, right? So then we have the moderation check. We have covered it multiple times. There is nothing new. In case there is some harmful content, it will catch it. And then we have our semantic classifier, the LLM based classification. It makes two decisions. As you see, it is mentioned here, whether the request is on topic as well as injection attempt. You can have two guardrails also separately as per your design, but I have put it into one function where the LLM will decide. As you see here, LLM is a security and topic classifier. It analyzes the user message and return the JSON object with exactly two fields: on topic true and false and injection attempt true and false. User is genuinely asking about AI, machine learning technology, software, or research. Injection attempt is user is trying to override the system instructions. So this is the way like this LLM will do the classification. And as you see, like we have used GPT-4 4 mini model. You can use any other model, even open one of the open source model which we have talked in one of the previous session, in order to reduce the cost. But these are the three guardrails, input guardrails that are added. And then we have the output guardrail also. First is the output guard moderation check. So if any harmful content which is written by the LLM, so think about that. It is not just LLM is producing the output, it is taking the help of search also. If you have gone through this program earlier on with me, then the search is performed. So search may contain malicious text, malicious content, and that can also be flagged by this output moderation. And then this is the quality check we have gone through. So the quality check, if there are two less findings, if there is no summary, then our system can abort and tripwire mechanism will trigger. And finally, if you see, there is another check, validate sources, in order to just to find whether the search has happened or not. So how we can check that? If you see in our hooks, we have added an extra thing, an extra variable. This is the variable whose value gets updated if any time the search is performed. Agent is handing off from search and going to another agent, then at that time we can find out whether this variable is updated or not. If the search agent is actually executed, then it means we are assuming the search has happened. So this is our third guardrail, and it is just checking if you are seeing here the search run is successful or not, and if it is not, then it is returning the tripwire the search has not run. So I think these are the six guardrails. These are just the only improvements which we have done in our program. I hope now the concept of guardrail is clear to you. And with that, we are ending the OpenAI SDK sessions which we have planned. I hope you have now get the overall idea about how OpenAI SDK is making agent creation, and working with the agent simpler as well as efficient and more productive, more reliable. So in the next session, we are going beyond agents. We are grounding AI with RAG vector databases and retrieval frameworks. And honestly, this is the arc I'm most excited about in the entire course, as we are moving away from agents that reason to agents that actually know things. And the difference is significant. Till then, I will wait for your comments and question below. I hope to see you soon. Bye.